I'm Curtis Schmidt. I'm a Framework Technical Director at Unreal. I'm here with Tim Tillotson, Gameplay Engineering Director. We're going to be introducing the new UEFN scene graph that's been built on top of the Verse programming language. This is going to be coming to UEFN soon and will eventually come out in the Unreal Engine as well as a new foundation for building game objects within the engine. Bit of an outline on the talk. I'm going to give you a background just on scene graphs, on Verse itself, some of the goals that we have in this whole project. Then I'm going to jump in and talk about the concepts that underpin the new scene graph. I'm going to give you a new preview of the workflows that we have in store. And then I'm going to jump in and do some talking on coding with the scene graph. Don't worry if you don't know Verse. I will also walk through some Verse basics as we go, so you don't have to know Verse to understand that portion of the talk. And then I'm going to hand it off to Tim, and he's going to go into a deeper dive on a game that we've been building internally to test all of this stuff and really pull it all together. So, background. Let's just start by talking about what is a scene graph, at least for the purposes of this talk. So, scene graphs, as we know, lots of terms are overloaded in the industry, so I'm going to give you at least my definition for the moment. Imagine you have a house. In our house, we've got some parts, and we want to be able to at least model and reason about this within our game. So you might just start by saying, well, I have a floor. Maybe I want to have a wall, but it needs to have a transform applied. It's got to rotate and be relatively offset from the floor. And you could structure that as a series of nodes. You have a floor with a transform and the walls underneath that. Then I'm probably going to add a bunch of other walls. And finally, I'm going to add a roof on top. So this structure that we've built, this tree or graph, that is what we're calling a scene graph here. So it's a unified structure for connecting all of the objects within our scene. And it comes with a bunch of benefits to us as game developers. So mainly, we can now reason about the scene, and we can have code that can walk up and down and around the scene and make updates to objects and reason about the relationships between these things. If you're familiar with web programming, this is pretty similar to the DOM, the document object model. In video games, we also sometimes call it a game object model, or in Unreal today, it's the actor and actor component system. But as you'll see as we get into the talk, this one is not actors, it's a new thing. Now I got to give you a bit of an outline on Verse. So what is Verse? Verse is the programming language that we introduced with UEFN last year. It is our programming language for the metaverse. And we had some pretty lofty goals when we released it. So first, it had to be an easy-to-learn language. We expect there to be tons of users who want to onboard to this. And the easier we can make it, the more likely they are to succeed. The language itself is compile time verifiable. It's runtime safe. We wanted to have a language that wouldn't be too hard to work in and isn't going to be crashing servers or crashing your games. That way, more players can engage with it for much longer. It also has a transactional memory model that underpins the language. So this is actually one of the only ways that we thought we could get 1 million different players or creators adding code that could work together. And one of our ideas around the metaverse is actually that we will have shared simulation. So if you imagine I write a car and I drive it into your world, we have to run all of your code together in some safe way. And so transactional memory is our way of allowing us to do that in a safe way that we can still reason about. We also want to have one language that kind of unifies things around data and code. We weren't imagining that Verse should be a language where you're calling out to external APIs, you're loading files from disk. We wanted to represent it as a unified system. So when we start thinking about things like how do I expose a mesh into Verse, that will be a Verse object rather than please call mesh file and load it into something. And finally, we designed it with the rigor sufficient for an open standard. So we plan to at least open this for specification or for open standard and allow others to implement the Verse language themselves sometime in the future. And as we built it, we realized that, well, a language on its own doesn't build a simulation engine. We are going to need a scene graph. And in fact, we think we need a scene graph that works very well with the Verse language. And so that's what we built here. This is a new scene graph that takes advantage of all the Verse characteristics and has some similar goals. So we want to have this be simple to learn for new creators. Fewer concepts, simple concepts that you can learn and apply rigorously and succeed along the way. It also has to scale to build any AAA content. We're going to use this to build Fortnite things, so it has to work for our content. That's going to make sure it scales across the board. And the scene graph itself has to be represented as Verse concepts. So this, again, isn't loading a file and then it turns it into some pseudo-representation of Verse. This is going to be Verse classes through and through. And it's going to take deep advantage of the type system. It also has to have an access model that enables that multi-user simulation that I was talking about. So if we want to write code that runs together, it needs to work well, but we're not messing with each other in bad ways. So we're going to be creating those systems along the way. And finally, we do plan to open this for open specification sometime in the future. Let's look at the concepts. So there's only 3, so we keep it simple. We have components, we have entities, and we have prefabs. So starting off with the basic building block, components, this is the data and logic that you use to build your game. If you've built any games and any game engines, you're probably familiar with components. We're leaning in heavily to them here, so it's composition-oriented design. Components can be as simple as a transform, mesh. It can also be purely logical, like a verse script. So if you want to use this to just build logical constructs like itemization, you could do that as well. But for most of the talk, I'm going to talk about visual things because they're way more fun on slides. Next up, we have entities. So entities are a container for your components. So if we wanted to build our lamppost here, this would be an entity. We can name it lamppost. It's going to contain a transform. It's going to contain our mesh. It's going to contain our gameplay and any other components you want to throw onto it. Entities have one other characteristic. They have hierarchy. So if we wanted to add a light into here, we can also create a sub-object, name it lamp. This is our child entity. And we can add the same components, but maybe we also add a light component so that it shines. One characteristic around the parenting here, this parenting represents object lifetime. So if in game we destroy the lamppost, the light's going with it. So it's not just there for organization in the tools, it's also a concept in the game that your code can take advantage of. And finally, we have prefabs. So prefabs are the highest level construct. They are a class that groups together multiple entities and their components. And in fact, a little bit of a cheat that I'm giving you on the code here, they are also an entity themselves. So at the verse level, a prefab is just another class that inherits from entity and has all of the default pieces that you added to the prefab inside of itself. So when you spawn one, it all comes together. And prefabs, big advantage here. I've created this, grouped it all together. Now I can spawn multiple copies of them very easily. And if I make changes to the prefab in the future, all my instances can get those changes. Let's take a look at all of that in the editor. So first off, adding entities to the scene, the simplest of actions. All you have to do, drag an entity from the actor panel, still called actors, and you can drag it into the world. We can add multiple entities. We can give them names, just renaming in the outliner here. And we can also parent them to one another. And there's our parent. So as I noted earlier, you can currently parent actors together in the engine, but that's a purely logical structure. So in the game, if the parent actor goes away, it doesn't guarantee that the child actors disappear unless you set up content in very specific ways. In this case, that is what that means. So if the lamppost goes away, the whole thing's going away. You can reparent child entities later through gameplay simulation if you want to keep them alive, but if by default, they go away. Next up, adding components. Again, pretty easy. There's an Add Components panel. We have a new set of components. These components are a flat list, so that's a little bit different than Unreal today if you're used to our hierarchical components. These ones are flat. We've also made the detail panel a little bit cleaner, nicer to work with. The components that are in here, we have a basic set, and then you can add any that you want through Verse. We'll be adding more of them over time. As you can see, I'm building up my actual lamppost from the first demo, so I'm just adding a mesh component and setting the meshes up appropriately. Next up, we can turn that into a prefab. So let's say we have our house here, so a much more complex one. Right-click, save as prefab, so you could build up the whole house in the scene, and when you're ready, you can turn it into a single prefab. I give it a name, and then it's going to pop up in our new prefab editor. And so you can see the entirety of the structure of entities and components all came with it. So this isn't just like one entity can become a prefab, it's the whole hierarchy. Then we can create instances of this. So all we have to do is drag drop from the content browser into our world. Now we can add instances of this prefab, go out, lay out our world, rotate them, make some changes. So this is a bit of a hint to 2 or 3 slides from now, but as you can see, we're able to make changes to each instance, so we can lay them out, and we're going to be able to layer on more changes. So now we have our little fishing village coming together. here's our changes. So with our prefabs, we can open up the base prefab, and any changes that we make in the base prefab, when we save, it's going to be applied to all of the versions that you've put into the world. So all the instances immediately inherit all the changes. So if we turn out all the lights, we can pop down, save this out, and our houses go dark. So very useful as you build big worlds that you don't have to go through and update thousands of houses to make one change. You can just make it once, apply it everywhere. You can also nest prefabs inside of prefabs. So it's prefabs all the way down. So here we might say, well, we really want to have some lights on these. So we can open up our prefab editor. And inside the Add Entities panel, we'll actually see our other prefabs. So we can add the lamp post from earlier, which I think might be named light post in the actual content. I know I named one opposite. Now when we save, it's going to cascade to all the instances again, and our scene is going to be lit. There we go. Finally, the big piece, we can make overrides at any layer of the prefab hierarchy. And I'll walk through this one a little bit more slowly so we can all see the actions here. So let's say that we have our house here, and we really want to change the windows. Maybe we want this one to be glowy and green. We can select just sub-pieces, and we can make any change we want to sub-entities, to the components on those entities. So here I'm changing out the mesh for one of the windows, and we've turned the light green. And this one's just applying to this one instance of the house. So if you had a carbon copy of the same house 1,000 times, it'll eventually get boring. You want to add some variety to your game. When we make those changes, the details panel is going to give us a little bit of hint about these overrides being applied. So if we look here, we are going to color in these bubbles. This means there's an override at this layer in the prefab. So you can always see if this is different than the base definition of the prefab. Now next up, let's say I go and make a change to my base. We can see what happens in the scene. So here I've decided I'm going to make them all purple instead of green. Same change, just being done in the base prefab. Apply the color. And when I save, only 2 of the houses are going to go purple. So what's happening here, well, we had 2 houses that were still inheriting their change from the base definition, and we had one that had overridden it. And because it overrode it in the scene, that is a higher level layering of changes, so it's going to win. So when we go in, we apply our new values. Next up, we have to recompose the scene. So these houses inherit those, and they inherit the lamppost. But the other version, it just sticks because it's more opinionated. And this is going to work through nested prefabs as deep down as you can go. So if we wanted to change just our lamp inside of our house, and then we update the real lamp afterwards, all those changes will layer on appropriately. And of course, if we want to get rid of them, we can just click on that little blue dot, and we can clear our override. Now we're inheriting from the base again. Not shown quite there, you can also lock values using the same flow. So you can actually select just override value, and that is going to force that instance to have that value forever. So even if you change the base to a different value, it's going to stick on the instance. This is just slightly different than delta serialization, which we do today, where we look at the base and we only store the difference. Here you can be explicit and say, I'd like to lock this in place forever, and it'll hold. Now let's try and look at this in code. So entity, we tried to keep entity and component as simple and clean as possible. So generally speaking, there is one function to do any one action. We don't yet have a ton of convenience functions per se. We expect the community to build those up, or we'll release them over time. But if you're trying to go for an open specification, keeping it simple is usually a good way to start. So we can unset our parent, we can get parent, we can ask questions about the hierarchy within the entities. We can attach new entities as children, and we can read them. We can attach components, we can get components, and we can dispose the entity. And I'm going to go through these in more detail, so don't worry if you didn't absorb them in one go. Component, a little bit different. It has a pointer to the entity that it's placed on, but in verse, pointers cannot be null. So this guarantees that you can always read the entity that you're placed on, and you don't have to do a bunch of null checks. So when you set up your component, you actually have to supply, I am going onto this entity, and I'm going to be there forever, and therefore I can avoid all those checks. We have a series of lifetime functions. These let you tie into different parts of the initialization of your objects. So if you were first being added to the scene and you wanted to render the mesh, we might run that code there. But if we want to run logic that updates every frame, that would start during begin simulation. We'll dive into those a little bit, but generally it's just the setup and teardown of your entities. We can also dispose them, and we have some capabilities for tying into delta ticking. So first thing we can do, we can write custom components. So let's say that we wanted to write a mover component here, just something that makes a thing move around in the world. All I have to do is inherit a class from verse. This is the verse syntax for inheriting a class, so name on the left, class on the right. And then I can also expose properties. This will make it show up in your add components window in UEFN, and then you can add them and you'll be able to set those fields per instance. We can spawn entities and add them into the world dynamically. So pretty much everything you saw us do in the tool, we're about to do it in code, so you can do all the same things. So spawning an entity, it's as simple as instancing the entity. So this is verse syntax for creating a new instance. We're creating a new entity named simple entity. Then we can attach it to another entity, and that will put it in the world. If you want something at the root of the world, we have a special entity called the simulation entity. So you can fetch that one, and that just means that you're kind of at the root of the world and you don't have a parent above that. Spawning prefabs, almost the same. So let's take our lamp post that we built earlier. When we build this, it's going to generate a prefab stub in an assets.digest.verse file for you. So the editor automatically generates this. We can see that it is a class that inherits from entity. So then all I have to do, just like entities, I can new one up, or instance one, if you're not familiar with that term. And then I can add it to the world, just like I did with the previous one. Attach entities, now I have my lamp in the world. We can attach new components, so you can dynamically add components to the entity at runtime. This one, we're actually going to build the entire lamp entity just from scratch. So I create a new instance of my entity. Then I'm going to call the attach components function. So this is some verse syntax for calling a function, and I'm going to build an array that's the parameter to the function. So that's the of array there. And then I'm going to create instances of the transform component, the mesh component, and I'm going to assign the light post mesh so that I can have my light post. And I'm also setting up the back pointer for this chain. Right now, this is what you're going to have to do when we first release it. In the future, Verse is going to be able to automatically reason about this and set the bidirectional pointer for you, but that will come with time. We can also get components. So components in the system, you can have multiple instances of a component on an entity. Some systems don't allow that. So what we do, we call get components, and we can pass the type of component that we want. This will return an array of components. Then we can iterate over them with our for loop. So this is just for every light, iterate over it. And then I'm going to set it to peach puff. Now, some components logically only have one instance. Verse makes this pretty easy. So we can get the same call, we get the components, and then we can read the index at 0. In some languages, reading off of an array might throw an exception or something you have to check for. But Verse has a concept of failure, where this call, because it's a square bracket call at our index at 0, that means it can fail. And an if block is a failure context that will handle and wrap this. So if I read over and there was none, this is just going to safely go, OK, that didn't happen. Go to the else block. Don't worry about it. So no worries about having to check for all of these things. Removing components, one call, dispose. So if you call dispose, it's going to remove the component from the entity above it, and then it's going to free all the resources. You cannot add the component back afterwards. You will have to create a new instance if you want to add it in. We kind of say components are rigid, but entities will be a little looser. Removing entities, you do have the option. You can dispose them. So disposing them will destroy them and all of their children along the way. So you can get rid of the entire chain. You cannot add them back if they've been disposed. This is a nice way to tell the system, I don't need this anymore. Please free up resources. Don't worry about holding all the memory up. But you can also unset the parent. And this will remove it from the scene graph tree. And then later on, you could add it back. So if you wanted to temporarily remove something from the scene, wait a few seconds, and then bring it back, you can do it that way. We have a series of simple query functions that you can use to write logic. So On entity, you can find all the sub-entities of a certain type of entity. This is how you'd look for like all the prefabs of one type. You can find entities with a component of a given type. You can find things with tags. And then we have some spatial querying. So you have to find things inside of a volume. So you want to know who's around you. This one will search down the tree. So given an entity, it looks for all of its children. We also have the option to look up the tree and find the parents. And I'll show you an example of this in action so you don't have to memorize them all in one go. So here what we're going to do is we are going to look for all of our health components. And we're being very generous in our game. So if the health is below 25 and the shield's below 25, we're going to give them a little bit more shield. So starting off, Verse has multi-line for loops. This is what we call our filtered for. So we're going to get the simulation entity because we want to look for everything in the world. Then we're going to find all the components of health component and iterate over them. So we're assigning each one to health comp, and then we're going to go and check for healthcomp.health and healthcomp.shield. What this does is that each of these is basically an AND statement. As long as they all come true, we're going to enter the do block of the for loop. If any of them fail, we're just going to go to the next item. So you can have as many checks in here as you want and kind of layer up all of your filtering logic. And if that succeeds, we're then going to add 20 to the shields. And so they get a nice boost. Finally, on the coding side, we have some lightweight ticking that you can tie into. So the ticks, the component has a tick events block, and it exposes two things. It exposes pre-physics and post-physics. These are callbacks that you can tie into if you want to receive events before physics runs in the engine or after. What you tend to be doing here is that if you wanted to apply an impulse to something and have it like fly through the world, you do that in pre-physics. And if you want to read the result, you do that in post-physics. So apply impulse, let physics run and do its thing, and then read out the results so you know where it is. And so on our game component, our custom component, we can do this just by subscribing a function, in this case on post-physics tick, and this will run every tick. And we will also pass you the delta time. This is something that UEFN doesn't have right now. Delta time lets us do smoother animation because we know the exact timing that has passed between the last tick and the current tick, instead of an approximation that we might have if we were just reading clocks at different times. Now I'm going to hand it off to Tim, and he's going to give you a little bit of an overview on bringing this all together into a more real game.
Thank you, Curtis. So one of the things we did is we had the scene graph and we looked at this, is we wanted to have some way to kind of battle test this. And so the first thing we did is I took one of the creative templates here, this River's Edge Island, and created basically a battle between two teams here. And so this is basically PvP mobile light. And we wanted to have the scene graph being kind of a core part of the gameplay here. And so we created basically a tower entity that will kind of position various places in the map that the players fight over. And those towers are being built with the scene graph. So here is an image of some of the art assets that they've created for these towers. And then you can see kind of the spheres. Those represent the location where the towers reside inside of this map. And so initially we started off by the art team creating all the different art assets. All of these are purely meshes and VFX. So there's no scene graph here, but these are the pieces we'll eventually hook into the scene graph. And the first thing we did is I actually created the same type of behavior that I wanted to do in the scene graph using just the devices that exist in UEFN today. And so this required taking visual things as well as behavioral things and combining them into kind of a composite basis to give me the same functionality I would have eventually in the scene graph. So here I have a destructible device that I put a mesh on for the tower. I have a turret that shoots. I have some upgrade devices and a script device. So there's a lot of pieces that kind of combine together to get the same behavior eventually we'll be able to achieve in the scene graph in a much simpler form. The key here is now all the behavior is in components, and all we have here is a visual representation of how these things are going to be presented inside of the scene. So here's kind of an example of how I started and created each of these towers. I just dragged an entity into the world. From that entity, I just right-click and create a prefab. That creates kind of this bucket to put all these pieces together into. From there, then I create sub-entities, in this case, the column, the core, and the crown of the tower. And then on each of those sub-entities, I then add components for each. In this case, mesh for the column and for the crown, and then VFX for that core. And then apply the various meshes in the appropriate place. And the key piece here is we have a lot of components to do a lot of different things. We're starting out small, but eventually, we envision this will be expanded out to many more capabilities that UE has in Fortnite we use today. And so once I have the components on there, then I reposition the sub-entities to where I'd like them to be in this prefab. And you'll notice now inside of the prefab, I have this overriding I can do for each of the different variants of the prefab. So now I have one tower I've created, and I want to create basically prefabs that inherit their behavior from the prior prefab. And so in this case, I will create a tower level 2, and I'll override the mesh for a higher level tower mesh, and I'll also override the gameplay tag here if I want to have like a level 2 or level 3. So now I have 3 prefabs, one for each level of this fire tower. And then I can expand this as well to have the different types of elemental towers. So my one prefab now, as I inherit from these things, turns into 12 different prefabs. Again, they all represent unique prefabs. They're inheriting purely data, and I'm overriding individual pieces that I want to have. So I can go back and change the level 1 fire tower and move things around, and every prefab in that chain will inherit those changes unless they've been overridden. Now, I take each one of these 12 towers and I actually want to make a composite tower. So in this case, I create a new prefab, and inside of this prefab, I take all of the prior prefabs and make them sub-entities inside of here. So I have a single entity that represents my initial 3 fire towers, as well as entities for every single other element type of tower. So now I can combine all of these together. In this case, I have a method here. I can use gameplay tags to go and enable or disable entities based on gameplay information. So here's an example of that kind of in world where I'm just switching out the different elements. So you kind of see the elemental VFX as well as some of the materials changing as I swap elements. And here's the same thing where I'm now going to upgrade and just enable the element of the tower, or the upgraded level of the tower, as well as playing a VFX in the middle. So you can have kind of the smooth transition between changing the prefab internally at runtime. And now I want to add some behavior. And so in this case, I want the tower to be able to shoot players as they come within range and enemies. And so now I've added a component. And in that component, I want to be able to create some attack logic. In this case, I look and see if a player is close enough. And if it is, then I'll create a beam VFX and then attach and then damage the player. And so here we have just shooting behavior on the tower. And here I've added some logic to give us the ability to then damage the tower. And when I cause enough damage, then have the VFX for destruction to play. So now I have a tower that can shoot the player as well as take damage and be destroyed. And here's all of that together in gameplay, including a menu that lets the player kind of choose to pay some resources and upgrade that tower. And then tying all these things together in that mobile game, here I have 2 teams competing over the center of the map between the 2 towers. And the battle that can occur is the 2 teams kind of try to destroy the other team's tower and let their minions rush to the other opponent's base. But really just brings all these pieces together now where the scene graph becomes kind of a core piece of your ability to create scenes and gameplay in a much richer way than you could in UEFN prior to this. So the key distinction between the existing devices that exist and the scene graph is that now we have a much richer way to specify behavior and interactions and overrides. Prior to this, for the devices, when I dragged them into the world, I had to basically re-drag them every single time. And if I wanted to move one around, all of them, in this case I had, I think it was 16 different towers in the world, I'd have to go to each individual one and modify them individually. Or now with the prefab, I can just modify one, and then all of the 16 will inherit that change. So much easier to iterate on large amounts of content in a scene. So here I'm listing out the various components we will release as part of the scene graph. There'll be transforms, attachment, meshes, collision volumes, particle systems, sound, lights, and then world text. And in Fortnite, we have the ability to damage and for AI to target them to specify what team, and then also to be able to interact with the tower, or the various objects. In this case, we had a tower. So we're also working on a lot of other types of things we want to expose via the scene graph. Cameras, movement, skeletal mesh, and animation and physics are some of the ones we will release later this year. And then longer term, we also want to do things with responsive input and modular vehicles. So a lot of the scene graph, because we're diving so deep into the core tech here, and there's a lot of changes we expect to come, we're starting experimental, which means we're kind of giving it out there in a state we want feedback from you to try this out, play with it, let us know what you think, challenges you run into, ways you want to see this improved. We really want to empower a lot more dynamic gameplay inside of the games that can be created inside of UEFN. The caveats, for those familiar with experimental, a new feature we're introducing in Verse, is you won't be able to publish to the world at large when it's experimental, but you will be able to play test with it. So you'll be able to iterate, share it with people, and make sure that your games are actually playable and enjoyable. And we will expect some amount of API breaking changes in this experimental phase. And so likely, if you use experimental, do expect that there will be some iteration when we finally remove that experimental flag. And we'd like to give a shout out to the hundreds at Epic who helped us do all this over the last several years, and plan on building on this quite dramatically over the next couple of years as well. So thank you all for your time, and turn the remainder of the time over for Q&A.
Okay. Thank you so much for the presentation. Really great to see you guys applying scene graphs to UEFN. Like you mentioned in the beginning, I've been using actors as essentially scene graphs. In my background, actually, I've been working with Open Scene Graph for many, many years before moving to game development. One thing that's from my background in Open Scene Graph is that your scene graph is not just your one particular element, but the scene graph is everything. And so you guys thinking of expanding beyond just making these prefabs to where the scene graph drives everything, so your entire world is one scene graph that has all these different components. And the real advantage to that is that you can also, one of the other things that you do in Open Scene Graph is you can bring in new assets, new other things. You can have a whole world, right? And you only load in what you need because you can trace through those components very quickly. So have you guys thought about kind of going beyond just these prefabs to making the whole thing a scene graph? And then the one last thing to that too is you can also, because you're representing objects, maybe we can get around the problem in UEFN that you can only have 300 megabytes of data. If you can pull from, let's say, maybe an online resource to pull in the 3D models, then you can actually have much larger content for people that want to play a game than just what's limited to the package data in your scene graph. So those are my two questions.
Sure. Tim, you want to do it? I don't
Sure.
know if my mic is live.
Yeah, so the answer is we are planning to let you build the whole scene out of just this new scene graph. We don't have all the pieces necessary to do that for the rich gameplay we have today. So we have a lot of content that already exists in UEFN and Fortnite. We want to be able to use that as well as the new scene graph we're building. So right now there's a place where both will coexist. But there will be a time when we imagine all the same powers that exist with our existing content will also be available in the scene graph, and you can build your entire game purely in the scene graph.
So, yeah, we can even go a little beyond it if you want to get dreamy on this. When we've talked about the metaverse context and having shared simulation, that's scene graphs in scene graphs to represent the additional worlds that are around you and those types of concepts, and negotiation between can this object leave this kind of bubble or not, and we'll build mechanisms to do that as well.
Yeah. I mean, essentially GLTF, which is supposed to be part of the metaverse, is a scene graph if you think about it. And so, yeah. Cool.
Thank you.
Hey guys, I have a couple of questions. Start with the easy one. Based on some of the verse examples, with the entity hierarchy, you know, class, stuff like that. A question comes to mind, are we going to be able to check type and compare type at runtime? Is that a verse change that's coming? Or is it just for those search functions?
So checking types, those search functions, essentially the way that those work is that we're still working a little bit on the verse characteristics around that, but that represented in verse parlance is more a function that takes in the component and then will be a decides function validating whether it gets returned. And so that's how the type checking idea can work. So to my knowledge, I mean, we can pull up a couple people from the audience who know the verse pieces in more depth, but being able to get the type of an object is not something that we are adding into verse.
Okay. Yeah, the next question. So also based on some of the ideas here in the example, so for example, changing the color of the light and also the tick function with the delta time brings to mind the fact that all these are server-side changes, right?
Yes.
I'm sure, you know, so I'm curious, like, how have discussions evolved internally about client-side verse scripting for us?
Right now, we're doing things to optimize how we communicate from the server to the client. As part of this example, we had to do a bunch of things to optimize that. In the future, we do have discussions ongoing about what running code on the client looks like. We don't have anything to say yet at this point, other than we are actively thinking about it a lot.
Okay, thank you.
Thank you.
Awesome, that was a great presentation. Looks super robust. I was just curious if you could elaborate anything on the world text component.
The world text component is, I'd say, very early days, and so we plan on expanding out the features there quite a bit, as well as eventually having the ability to have custom UI that we put in the world in various ways. But yeah, we're, again, very early days iteration there. So I would say some of these just came online like very shortly before the demo. So there's a lot of very early pieces here that will get much better over time.
Okay, thanks.
Hello, thank you so much for the talk. And in your demo, like based on the for 12 different towers, you basically have 12 different prefabs. So I was wondering, for those scene graphs, is it possible for the current version to construct procedural generated instance out of like single prefab with like modular meshes?
The answer is yes. Everything that I created in the editor, you could have done at runtime as well.
Yeah,
so everything could have been procedural.
Yeah.
So as long as we have like custom components to control those generations, right?
Yep.
Yeah, you can write custom verse components that would do all of that, yes.
Yeah.
And if you're
Thank you.
curious, we built the demo before I got spawning working, and so that's why we're doing turning on and off of the prefabs in that portion of the demo. We could have spawned them dynamically at runtime now as well, because that's now working.
Yeah, thank you so much.
Hi, Tom Jank. I have two questions. One about the damage aspect of the entity the component. Is that something that will be similar to like the damageable interface, where we can receive when it gets damaged and it gets back? Are we going to know like that interaction events between between characters and things?
There's two parts of this. One is, yes, you will be able to put damageable interface on things. There are very specific interactions with the weapons and abilities that exist inside of Fortnite that are only exposed through this component. And so some of the behavior we'll be able to use with the damageable interface. Some of them, when they involve interactions that aren't through verse yet, we'll have to use the existing components to get those things picked up with kind of the Fortnite things that have not yet tied to those interfaces.
Gotcha. All right. And then with memory limits, like we've spawning in things and things, do we know yet how that's going to be culled or checked? Like what kind of limitations will we have on spawning lots of new things?
Right now, this is not optimized in any way, shape, or form, and we have lots of plans to optimize things quite a bit. And so I would say that the initial experimental version will not be in an optimal form, but we plan on making it at least as optimal as existing actors and components in UE.
Great. Thank you so much.
So I'm not super familiar with scene graph, but I'm curious about like how, or like, you know, the ideas behind it, but how does this affect migrating stuff? So if I want to migrate a prefab or an entities that I've created in one project to another project, because I feel like that will be a really common workflow.
So they are a U asset, like any U asset. So the migration is akin to migrating any of the other content that you do between two projects in UE. So moving the U assets across should work. I have to test that, of course, but migrating them across should be fine. The code, likewise, will migrate across. If you were trying to migrate between actors into the new scene graph, that's currently more of a manual procedure, but they're both going to coexist together, so you'll be able to use both ideas together for any foreseeable future.
Yeah, I will add there are some data paths right now for the projects that are baked in to the prefab, and so we'll probably have to provide some migration tools in the future if we want to allow that.
Yeah. Thank you.
Yeah, hi. A little trend I've been seeing is that UEFN tends to be a little bit of a testing ground before moving to the big boy Unreal. Is this a similar thing with the prefab, or is this just staying in UEFN?
It's moving into Unreal eventually. This will become new foundational tech for building content in the Unreal Engine.
All right, thank you.
Thanks.
Hi. When it comes to transforms and the transform component and all that, is that going to be based on a world space or a local space?
So transform components, we have world space as an option, and then there's an attachment system on top of that. So you'll be able to have an attachment component that says, I'd like to be relatively transformed to my parent entity, or likewise, we'll eventually add socket attachment or various other styles of attachment. So in those kind of more complex cases where you're trying to do like a physics joint system or attach to a bone on a character, you can opt into that path as well.
Oh, fantastic. Great. Thank you.
Hi. This looks awesome. Super excited to get my hands on it. Just out of curiosity, is it built around the current actor component model in Unreal or built on mass entity?
So this builds on top of UObject at the moment. That's at least both component and entity are inheriting from UObject. We are not tied to that implementation detail. We could potentially change that in the future as well to try and make it even more lightweight. Behind the scenes, we could take advantage of mass in certain ways, but it's not directly built on top of mass.
Okay.
But certainly an implementation detail that we could choose to use if we want to try and optimize this like crazy.
Sweet. Thanks.
I can imagine that if you make a lot of prefabs, you can get to like thousands of the exact same identical mesh, right? And so are you guys looking into how you could take advantage of like instant static meshes, that kind of concept, rather than static meshes for all of your prefabs? So essentially you have just one instant static mesh container for all of the duplicated components of the prefabs. Are you guys exploring that?
Yes.
Okay. And is that implemented? Is that?
It's definitely not implemented.
Okay.
But I have a lot of rendering engineers at UE who are interested in seeing if we can make that happen.
That's exactly what I'm doing with your actors, is using that technique. But yeah, thank you.
Thank you.
Hey, great talk. Maybe not a super high priority, but wondering what's your thoughts about interoperability with OpenUSD?
So we're treating OpenUSD as kind of an interchange format. So we'd be able to ingest it into the engine. This isn't currently working, but yes, you'd be able to ingest it into the engine and it would turn it into entities and components. And we should be able to go the other way around. We haven't implemented it, but the concepts map well enough one-to-one. We would still have to add extensions into OpenUSD to keep the gameplay logic alive through that round tripping, because OpenUSD is very good at structuring the scene, but doesn't carry the sort of living logic that you have with a real-time simulation, which is what the scene graph is optimized for. But it's certainly something that we are going to look into.
Oh, awesome, awesome. That means you guys will get it happen one day or another.
One day.
One day. Okay, thank you.
Thanks.
All right, great talk. Super awesome. What things do you not see ever going to scene graph, like maybe animations? Is there some things that are hard no on the scene graph?
No. Yeah, nothing that we are closing any doors on. We plan to try and move as much as we can and everything eventually for some definition of eventually.
Outstanding.
Yeah, I would say there's probably some legacy content that
Right.
we will give the same powers, but we may not migrate that content per se.
Am I to understand that the original devices are essentially made as prefabs at some point, and like we deconstruct those? Is that going to be the kind of plan, or going from scratch?
We will give you the ability eventually to be able to build devices directly using the scene graph. We will not give all of the internal source for all of the devices that exist, But we will give you the ability to rebuild most of those devices, yes.
Outstanding. Welcome to the future. Thank you.
Yeah. Again, that's going to take us a while, so this isn't going to be on day one. Yeah.
Hi, thank you for the talk. So I'm never using Unreal or Unreal Engine Fortnite before. So my question is like, if I want to start try using UEFN this, as far as I understood, the open scene graph is still an experimental, which is when I build it, I won't be able to publish it, right? Then should I wait? Should I try with the current one, or is it better for me try the open scene graph and release it when this is not experimental anymore?
So the UEFN today, you can publish to the world, make games, make money on that. This we're planning on releasing roughly Q2 timeframe, and so, but it will be experimental in that timeframe. And so we're planning on making it so you can play test this, you can iterate on your experience, but if you want to make money in that timeframe, this is not the appropriate tool yet. And we're really going to get feedback in that time. And then I think roughly end of summer is when we want to be able to take off the tag and let you publish. Those are rough timelines. They're not like solid locked in stone. So they're just as, communicating where we're at, where we think our development timelines fall, and let you plan accordingly.
Ah, okay. Thank you.
Any other questions? Oh, good.
Thanks for the speech. If I understand correctly, you will delete the actors and component in Unreal Engine someday. Yeah, is that right?
Yes, so the goal is long-term that the same things we're building out here in UEFN will go to the Unreal Engine. A lot of the tech we're building here is tied to Verse, so a lot of it's going to come along when we bring all of Verse to the Unreal Engine as well.
Okay, when do you think that will happen? Like, is that a timeline? 3 years or? No?
We have not communicated a timeline on that yet. I would say we are actively in internal discussions on that, though.
Okay, thanks.
Hi, great presentation. I think it's a great direction to head to. I used to be a web developer, so it's kind of like a very similar DOM structure to a web developer. So I just have one question. I saw yesterday during Unreal's State of Unreal about adding meta-human support for the UEFN. So I'm just wondering if that's going to be supported through the scene graph as well.
We haven't started talking about MetaHuman specifically coming online. Eventually everything. At the moment, MetaHuman is still being brought in as, I believe, the MetaHuman actors. I don't know MetaHuman super well, but it's being brought in, the same way so that you can publish and do all of that. Okay. When we start bringing animation and all of those characteristics online, we'll be able to use the MetaHuman tech with it.
Okay.
Yes, I would say that's going to be a little bit, mainly because there's a lot of work to get even skinned down actors and animations in here. Mm-hmm. But it is on the roadmap, yes.
Okay, thank you.
Hi, thanks for the great talk. Just curious how exactly you see it working with the interoperability between like different scene graphs, different worlds, I guess. Is that something that the user gets to define when they set up like their verse structure for this particular scene graph, or is that something that's enforced by like the engine?
Still incredibly speculative right now. We're talking about it and kind of conceptualizing how that would work. So we don't have any real answer that I could say at the moment. But
no worries, thanks.
Yeah, it's the idea.
Yeah, we do have things we built internally, particularly when you've seen in the past the Fortnite creative content like in BR, or we have ways of interacting with other actor content here. But those are things we have to fully flesh out here, so we don't have anything other than discussions we're currently having in that space. All right, for any questions, and thank everyone, and call it a day. Thank you.